series, we are putting as per the industry standard seminar web series that we are hosting from the SmartGaon side. Today we have a session on scope and career opportunity in cloud computing. Today we have our honorable guest, Mr. Ayan Sircar, who is industry standard, who is having this experience in cloud computing. He is working right now in the Google. As we know, everyone knows about the company. Just a second, I'm just getting some, just 2 minutes. Okay, so we have the speaker from the Google in today's session, in which he will be covering the scope and career opportunity in the cloud computing. I'll just take a couple of words for the introduction for the speaker. So Mr. Ayan is a technologist and a strategist in Google Inc. He is working in California. He is currently working in the engineering leader and having 22 plus years of experience in IT project management, electronic design automation, distributed system, cloud computing, and multiple technologies. He graduated in Jadavpur University in 1998, and after that, he is continue on this turn. So, on behalf of everyone, we are welcoming Mr. Ayan. Mr. Ayan, are you able to? Okay, thank you, sir, for today's session. This will surely helps our students to give it out, like to decide it on like what is cloud computing, what are the career opportunities in that, how they can enhance their career into the this IT industries, and what is the upcoming trend that is going on in the industries. So we have the, I think you are already aware, but I'll just put it out a brief details. Like the audience we are having is the students from the various college who are in the third year or fourth year or the second year of the engineering, and they will be like, of course, as part of the engineering program, they are having a vision to come into the software industries or the IT industries. So this seminar will definitely going to work on that, and this will help. So
Sure.
Again, warm welcome and many thanks, Angie, for taking your time and giving us this guidance and details. So over to you, please.
Sure. Thank you so much, Navneet, and very good morning to everyone. So unfortunately, due to the current situation, we are all doing this virtually, and I'm pretty much flying blind because I cannot see most of the people, and I have opened this chat on the side. I'm hoping that everybody is able to see the presentation. And what we would do is after every few slides, I guess we'd pause. Is that correct, Navneet? And then we'll take
Yes.
questions. All right. And this is supposed to be an interactive session, so feel free to add questions here in the chat room, or when we take a pause, we can discuss. So without much ado, we can start. And thank you so much, Navneet, for the introduction. We'll go to the next slide and start from there. Okay. So today we will talk about briefly why, what, and how of cloud computing. Why do we even need it, and what does it mean, and how do we achieve it? Then we'll move to scope and application, some examples, and then we'll move to career basics, specialization, and current challenges, maybe some open problems, open for discussions, and at the end, some of the references. All right, so
sorry to interrupt, Ayanji, but I just want ki sorry, मैंने भी start किया तो probably most of the things मैंने भी English से start किया, but if you'll have something more on the Hindi and English combination, that will really help the students there. I
Hindi and
know
English
that it will be a bit of that, but
sorry,
yeah, whatever. So.
Anyway,
Yeah, if we can continue on the Hindi and English combination, that will also work like here.
Okay, I'll try that. I'm not a native Hindi speaker.
I know.
But feel free to interrupt if someone is not understanding me. I'll try to speak slowly and
yes.
interrupt and let me know right there.
Yes, and we will be helping it here with the students if they are having anything. So students, if you have something, You can just
Sure.
put a question in anything. We will take it out to the Ayan ji in a way. Okay.
Yeah.
Thank you, sir. Yeah,
Feel free
you
to
can go ahead.
interrupt me at any time. Yep. Yep.
Yeah,
So
sure.
I'm assuming most of you already know that the traditional computing has been, in a small box or a one computer, and then it started with multiprocessing. And after a few years, I mean, in starting from early 90s, if I may, most of the systems were self-contained. You'd see in your labs at that time that few computers are interconnected, even in early 2000s. After that, so from 2000 onwards, the Web 2.0 boom started, and that is when people around the globe, they started using services. I mean, Microsoft and everybody used to produce CDs and DVDs and Blu-rays, and they would you would bring them and install. And nowadays, everything over the air. So what 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 was needed is, I mean, when people from all around the world are using a service through internet, that means that there should be either a central or a distributed machines which should take care of those. And nowadays we call them data centers. But the premise is that now in today we are having about 138 participants. Now let's assume that we started with 10, and maybe one computer was enough. And let's assume that it is a very heavy process, and when it expands to 50 participants, to one or two computer is not enough anymore, and it goes to 150 participants. Now we need 10 of them. So how do we do it? I mean, traditionally, technicians would go and hardware them and through network cables and whatnot. And we cannot have that luxury or time anymore. And similarly, from 150 participants, if it drops down to 20, all these wirings and everything we prepared are wasted resources. So to do that, one word that defines why we need cloud computing is scaling. And which means, and probably all of these I'm saying you guys already know, so I'm repeating a little bit. um, but and you understand the scaling concept. And the more we scale, it also needs to have hierarchy. What it means is, if there are a bunch of workload that is getting processed in India, there are a bunch getting in Australia, and some are getting here in US, then, and if your central server or the pool of server that is residing in India, then there would be a lot of churn and latency and thrashing while communicating from US to India, or India to Australia, and so on and so forth. So you need local servers. So you need some of them in Australia, some of them in India, some of them in US. Just a pathological example. And then they will need to communicate among each other. We would not get into much detail there. It's a very big subject, that how do
I
we
know.
partition data and all. But this is overall, bird's eye view. And this is the premise of why we need cloud computing: to serve and make the data available whenever we need, and expand and contract whenever we need. The other problem is that all the machines, they can fail at any time. If we have 10 machines, if two fails, we know how to manage. If there are 100,000 machines or CPUs that are running, and every minute one or two fails randomly, there is no way manually we can track that. And when machines are failing, then we need to update that capacity. And then when those are not needed, we need to reduce capacity. That is our second premise why we need cloud computing. Now, so essentially, now when we kind of touched a little bit on what of that, what means, we know why we need it. Now we have to plan, what do we want to do, or what are we planning as a service for cloud computing. We talked about, we cannot have server pool in India to serve worldwide, for obvious reasons, that, I mean, there will be a lot of latency and there is central control. If something, let's say we build a server farm in Garhwal somewhere, and there is an earthquake which is very frequent there, and the data center gets damaged, the entire service worldwide is going to be down. So you'd find in literatures, in throughout the internet, if you search that, for this we also do geo replications, and you need at least 3 data centers across the globe, so that if one fails, other two can serve. So which the first point comes as no permanent central control. If the second basic premise is, if for the what is, you cannot have single authority which can fail and bring down the service, which means it has to be distributed. And that is why you would see that in subsequent slides, when we talk about distributed system, that is the root of or the crux of how cloud computing is built. One other small thing I want to mention in what it is more sort of a conjecture or a proven rule that we cannot achieve consistency, availability, or network partition all three at the same time. So consistency means that, if someone, let's say there's a banking application and someone in India writes or adds $10 to an account, or 100 rupees to an account, someone sitting in Australia should see the same data, that their bank account has been updated by 100 rupees. And there should not be disparity. Otherwise, what would happen is, if the bank account was empty and someone kind of withdrew, or let's say bank account had 1,000 rupees, someone withdrew 500 there. In Australia, someone withdrew 800, then you suddenly have a overdraft, because the 500 withdrawal was not reflected in Australia. So that is consistency. Availability means the data should be available everywhere, wherever the service is there worldwide. And network partition means when there is let's say there is a transatlantic line between US and India, and high-speed data is going between them, and that line is getting cut, or there's no connection between these two continents. We should still be able to serve data in those two even without this connection. So that is what is network partition tolerance. So you can look up cap theorem. We'll not go down more into this, but at the end, maybe if you have questions, we can talk about it. Now, the third one is most important, is how, now we know why, we know how, what are we going to do, and how are we going to achieve that? So as you guys are studying in college, you would see that maybe, you are studying about network architecture and network theorems, computer algorithms and whatnot. And you'd see that the first step would be that, when you're running even in a single computer, you want to run multiple processes. Even if you don't realize, in your computer, there are hundreds of processes that are running and they're communicating within each other. That is a miniature version of a distributed systems. There are multi-threaded and they are multi-processed. So when they communicate with each other, think about, take one of those process and put that as a service in your location. If you're in Lucknow, then assume that one process is running in Lucknow, and take one other process from your computer and put that in, let's say, Allahabad. And these two, when they communicate, this would be something sort of a distributed system which is spanning across globe, although in a small scale. So each of these services, when they're independent, as we have said, there is no permanent control or central control. Each of these can fail, right? We said every machine can fail. These services can also fail. So there should be someone else who takes over the work that they are doing so that the service is uninterrupted. So let me, so essentially, if we recap, what we want to do is we want to have a distributed system which are autonomous. All of the services are serving independently. They don't care about how others are thinking about them. If they get a query, they would just respond without thinking about whether the other service is able to handle or not. And they should be fail-safe in a sense. If that process dies or that service dies, someone else is there to take care of that. So we'll take a brief moment here, whether these concepts are clear, and then we'll move to the next slide. Are there any questions for these?
Yeah, I think this is pretty much clear. There is one question that we have from Tushar Srivastava, but before there,
Okay.
I just wanted to add it out. One multi-processing example that probably I will give it out to students, since they are in right now in the engineering student. So you will be playing the game and then you will be running the songs on your computer. So that is also what ING provided, that it's if we are talking about the local example, it's the multi-processing. So Ayanji, there is one question from Tushar. He's asking that how much cost when we start a new sub center?
New subcenter, new data center, sure.
New data center, right? It's like,
Right.
yeah. Yep, yep.
The question is, how much cost is there?
Right. Yep.
Okay, so the answer actually varies based on at what scale we are looking for. Say you are just launching your service in your city, and you have to guesstimate that how many. Let's say you are forming a startup and you want to launch your service in a very small scale. Maybe it's a food delivery service, just picking an example, and that operates within your city. Then you have to estimate how many people are living there, what percentage of them are probably going to use, and then you can back calculate and see how many machines you need. So that is how you can estimate. But on the other hand, if you look at Google scale or Amazon scale, they are distributed worldwide 24/7, very highly reliable. If you look up in internet, you will see the reliability percentage may be as high as 6 nines, which means 99.9 99.49 of the time they are active, and 0.00001 time percent of time they can be down. So if you want to provide that kind of reliability, you have to not only have distributed data centers, you have to have replication and backup, so that if something fails, you instantly have mirroring of those data. So there is no um, one thumb rule there that you can estimate what could be a typical cost, but that's the guidance of how you can compute that.
Yep. I think that answers Tushar things, ING.
Sure, is that
So
clear?
yeah, ING. Yeah,
Okay.
yeah. Okay.
All right, let's go to
Thank
the
you.
next slide. Okay, thank you.
Uh, where to start being? There is one more question, Angie. We
Okay.
just now got it out. Where to start for being a network architect? Means I think he wanted to ask like how we can start being as a network architect. What are the steps students needs to do, or like how to proceed on becoming the network architect?
Okay. Network architect, although has nothing to do with as such cloud computing or distributed systems, but you can be a network architect and be in cloud computing domain. These are different. But first of all, in your college, if you love networking, there would be multiple networking courses. One should be on networking protocol. One should be on the networking algorithms at least, and maybe more. Network optimization. Read those very well. You guys have, honestly, now it's the best time to ramp up on whatever you're interested in, and clear the basics very well. You would see that
Agreed.
once you get into a job, you may not get that time. There would be other learning opportunities there, but that is the first step: clear your basics. Second thing, if for a network architect, you have to know the network topology or how the network process are working very well. Now the flavor comes after that. If you want to be a network engineer, you have to be a good network engineer before you want to be an architect. If I understand the question correctly, if you want to be a network architect, you want to design fabric networking between multiple data centers or multiple sites of your company, and you want to define, for example, how the data should be transmitted, how they should, what would be the latency and throughput, and so on and so forth. For that,
Correct.
there are two different ways. One is, if you want to be a network expert on all of those, and generically you want to define an architecture topology no matter what company you are for, you can probably pursue your study up to PhD or postdoc, and then go from there. You have to have a really thorough grasp. Second way of doing it, which is a bit shortcut, is you'd say that Cisco or Juniper or other networking providers, they would have CCNR and lots of courses that say I am certified Cisco professional and whatnot. Those would be one step into being a network architect, and you can only serve after certified those companies which adopt that company's networking gears and protocols. But the problem is that you are being very specific in that area, and sure, you can expand with another company, but it is not a generic one. So you have to choose which path you want. If you, I'm assuming that you are really passionate. In that case, I would suggest the first one. Clear your basics first, and then you can go that route. In the meantime, sure, you can try certification and get a flavor and work for a little bit and see whether you like it or not.
Yep. I think that will answer. Thank you, sir. I that covers his questions. Nilesh confirmed it out.
Okay, great.
Okay, we are good to go. Thank you.
Okay,
Yep,
thank
we
you.
can continue.
Okay, so now we are in, so we are, let's talk about scope and application. And this will give you that although distributed system and cloud computing has been picking up, it is projected to grow more than 2x in next 5 years or next 4 years. And with that, whenever we grow something in size, like when we are, when we try to cook khichdi, right? I mean, and we cook it for five people or in a household, and suddenly we want to cook it for our whole mahalla. Then cooking that khichdi becomes a lot more cumbersome, more complex. You have to think more how much spices to put and how to control the heat and whatnot. Similarly, even though it seems that in again, I am sorry, I apologize that I'm not speaking too much Hindi, because it is not
No,
because
no,
I can't speak, but I can speak, but you guys will probably laugh. That's why I'm trying to avoid. But
no
if
problem. No problem,
okay,
Angie. I think
if you
it would
guys
be
are
better
not able to
because we
understand
all.
something, sure, please stop me if you guys are not able to understand something.
Sure,
So
yeah, we'll do that. We'll
okay,
do that.
so what I was trying to say is that you may think that, oh, okay, next 5 years or next 4 years is only going to double, but it's not
Mm,
that. Even if it doubles, the amount of complexity and amount of scope is going to increase exponentially. Because as if with that cooking example, you can see, as you increase the volume, it adds to more complexity. So that is one
correct.
of the key challenges now. Not only that, I mean, you'd see later on in the slides that as the complexity increases, as the volume of traffic increases, you have to solve more challenges, in the sense how do now, a few days back we had SD video transfer. Now we have gone up to 4K plus video
Mm,
transmission. Tomorrow, 2 year down the line, it would be even more fine tuned and
fine
even
tune.
more volume, because number of subscribers are going to increase. We are going to have augmented reality, virtual reality, everything which takes more bandwidth. How are you going to solve them? How are you going to have a presence of, maybe I'm talking now through a computer now in Zoom. 5 year down the line, my 3D hologram projection will be there in the classroom or everywhere in whoever is doing. Think about how much
Right.
bandwidth that takes, and how are you going to solve that? So, and multiply that by this double projection of this talks about revenue. 307 about 400 billion revenue now. It is going to be 850 billion in 2025. But this is the scope. If whatever you can imagine, that is going to be the complexity. There in throughout the slides, I have put some of the links, and you can click them and go and view more. So it also gives some of the application. They talked about scope. The applications are definitely data storage and processing. What it means is, um, let's say you guys have, I'm sure, have heard about machine learning and data mining and all of those, right? Data scientists. And one of the key
Yep.
challenge is to sort of make meaning out of garbage data. So think about a very small example is, if you have a Microsoft computer, there are processors which run on the background that collects all the stack traces and continuously monitors on the background that which process fails and why did they fail. And they, if with your permission, they send out that data to Microsoft. Every company does that, even in your Mac or even in Linux, you can do those. And so now from your computer, uh, imagine that that's in a global scale, and think about how much data the network is going to collect, or a service or a company is going to collect to determine whether their application is malfunctioning. And this is just an example, and you have to make meaning out of that, you know terabytes or petabytes of data, that where things went wrong. And you have to do it quickly because your service is down and you have to fix it. One practical example is, for example, Amazon. Amazon is a very high volume traffic. In every second, they are like, I think now it should be like 100K, 200K revenue transaction is going on. And
Mm,
every minute you can compute how much revenue they're losing. And worldwide, that traffic, if it goes down, it has happened many times on Black Friday and Prime Day and whatnot. The entire company comes together and tries to analyze that. If you want to do such a thing on the spur of the moment, it is never possible. So you have to build those systems upfront, and you have to also predict that, okay, this is my data that is getting collected every minute. I want to build a machine learning system or data mining system to predict that if my threshold may be, I mean, I planned my machine, for example, for 1 billion user, and suddenly I got 1.5 billion user. My system, whether my system is going to crash, or can I do some buffering? Can I do auto expansion of my cluster to handle that?
Correct.
Those kind of things.
Correct.
So streaming services is another great example. Everybody loves YouTube nowadays, and it is expanding like anything. And everybody has YouTube channel. They are making money, which is great. Think about when let's talk about India. In India, I guess, I don't know the exact percent. I'll guess probably 5%. I mean, if it is too many, I mean, if I take the maximum, probably 5% have access to computer, and they are on YouTube maybe. And Facebook and other companies are now promoting that everybody should have access. Even if they don't have access to computer, they have cell phones, smartphones. They are accessing their
Correct.
through YouTube, through that they are uploading video, TikTok and whatnot. Think about that explosion. When everybody signs up, I mean, India has like 8 billion people now. Even if a fraction increases, how much data are we going to distribute? So that is one other thing. And video always take a lot more bandwidth than general data. E-commerce is another thing. I want to purchase something. I mean, I'm sitting here in Sunnyvale in US. I want to purchase something in Flipkart maybe to send something in my home. And that transaction has to happen in near real time, because for example, during this COVID situation, everybody wants oxygen tanks or oxygen concentrators and even small bottles of
Mm.
the, and maybe Flipkart has available, I want to buy that, and if it is slow, by the time I add it to the cart and check out, it's sold out. That doesn't help either them or me, or even in regular scenario. So that needs to be there um, seamlessly. The last point, I mean, there's many applications. I didn't even talk about routers and all of those lower level details, but the last point is research and technologies, right? Breakthrough technologies. Two great tools is, I'm not sure whether you guys have heard about the AlphaFold breakthrough, which Google had a few months back actually. For many years, probably past 30, 40 years, even if not more, we have been trying to find certain protein structures which would help us predict the cancer cell protein structures, and essentially
Okay.
discover medicines. So why we could not do that is because it takes enormous amount of CPU cycles. Think again, let me explain why. Just making that statement is not enough. I'm assuming that everybody remembers what is a permutation, right? So think
Mhm.
about how the permutation grows. So if you have a 3-digit permutation, factorial of 1, 2, 3 versus factorial of 1, 2, 3, 4, how the number grows. And a gene folding is a very large sequence of ACTG. Those, if you recall how the gene is constructed, the double helix ACTG are the proteins, and then you want to arrange those proteins in such a way that it matches how we want to go and attack a cancer cell. Because similar to COVID, it attaches cancers or malfunctions in cell, and you want to predict what would happen, how a cancer cell malfunctions, so that you can find out the sort of the counter gene of that to attack those cells. And if these are like 50,000, 60,000 character long, a factorial of 50,000 or factorial of 60,000, you have to compute all those permutations to find one. So that is the scale of the problem. And with the current advancement of compute power and distributed systems, Google was able to do that. Second example is search for extraterrestrial intelligence. So everybody wants to find that if there are other planets where there are human-like people or other aliens, And you can think about how vast is universe, how many stars are there, how many planets are there, and so on, so and so forth. And SETI tries to find that and say that, hey, I mean, so many light years away, there might be something. So these are the two examples of the exoplanetary scale. And the more with the more advanced distributed systems or compute power increase or parallelization, it is making progress. I'm sure with SpaceX going to Mars, there will be more complex problems, and you guys are now getting equipped to find more breakthrough technologies that even with the realm of current compute power, how you can do more than these. Maybe you would come up with some theory or some breakthrough in algorithm or parallelization that would be able to solve SETI, even with the current compute power. So that is the scope of how you can leverage your knowledge and do more. All right, so we'll after the real life example, we'll take another pause.
Yep, sure.
So I picked 3 companies where I worked out of many, of course. The current one, Google, as here the data is backdated, and I am unfortunately I cannot reveal the current stats, but I ensured that these are all publicly available data. So
Mm-hmm.
and so few years back, Google typically had more than 21 globally distributed data centers and more than 2 million machines. And some of the real life big distributed systems or cloud level or global level softwares where Colossus, Chubby is distributed key, Bigtable you guys might have heard. It's a really large database distributed. Spanner is also another favor of distributed database. Bigtable is more structured. Spanner is more of NoSQL data. Um, and both has both flavors, by the way. So why these are important is because these are all in the background, and when you access Gmail or YouTube or public cloud, you do it seamlessly. If you send a Gmail, in fact, if you open up two laptops, and if you start typing one email, every character should be reflected in your other laptop. This is how seamless and fast Gmail has been done. And you can understand that to achieve that fairness, and it is not within the room. I mean, if your friend is in some other continent, and if you're doing that and both of them are logged into the same account, you'd see that pretty much instantly. And you guys are the people who are in the first 2 bullets in Google, right? You make that happen. You would write application code also, but you are the people who are going to graduate and essentially work in those areas which make all these applications possible. So
Correct.
Amazon's example was Amazon Alexa. Maybe you guys have heard about Amazon Alexa, which is trying to make smart assistant. It can be in a device or your phone or in your car. And when you talk to that assistant, there are a lot of improvements that needs to be done. But when you try to converse with them, I'll just try to give one example of the path it traverses. We also have to do a time check, right? Okay. So the path it traverses. So when you talk to your Alexa device or even Google Home, same thing, or Siri, when you talk to that device, they capture the audio, they send it to the cloud, and from the cloud it translates that to text. Then that text, maybe you said, play me a Michael Jackson video or Michael Jackson song, or you might have said that what is the score of a T20 cricket match between India and Pakistan, right? Something like that. And then when it gets to translates to text, then it tries to understand what are you talking about? Is it a question? Is it a command? Like, you can also say, hey, turn off the lights, right? All of those. And it
Correct.
could be a very subjective question, like, I mean, how many calories in a spoon of sugar? Or can I put a 10 foot by 10 foot box in my Toyota Prius's trunk? Anything is possible, and you have to understand what you're talking about. It has to analyze them, find the context, find the answer, and play it back. From the answer, translate that to audio, send it back to your device, and play it back, all within 1200 microseconds, or 1200 milliseconds. So
Millisecond.
the attention span of a human that in a real conversation is 1.2 seconds. If it is more than that, you would find odd. So you have to do all of these within that time. So this is possible because of distributed system and cloud computing. Same is in Amazon Prime. So when you have Prime Day, there are millions of people all over the all over the globe logging in at the same time. So for you would hear a term called TPS, or transaction per second. And for Amazon Prime, for example, the TPS is in the range of probably a few million requests per second. And you have to sort of distribute that, load balance it, and serve those requests concurrently so that everybody is satisfied. AWS, everybody probably heard about AWS, similar to Google Cloud, and they are the backbone for all of these services. Third one is, for example, Cisco, and you guys are probably aware of Reliance Jio, one of the largest mobile network in India. And
Correct.
Cisco, at least a couple of years back, they used to serve and contract with Reliance Jio to provide the backbone. And so there is some technical term here which you may not be familiar with. For example, top of the rack switch. What it means is that everybody has routers in their home, right? Now think about, you're creating a network of routers. There are leaf level routers, and then there is a hierarchy of router which are intermediate. So all of them are forming a tree-like structure. And there is one top router that controls this subtree. It forms a tree, right? This is a subtree. Now think about 2,000 of those routers, right? That is the top of the rack. And each of these leaf level routers are also connected to at most 65,000, sort of like 65K machines or something. So 65K into multiplied by that one top of the rack, 65K into number of leaves into how it goes back to the top of the rack, and 2K such top of the rack. This is controlling entire geo network in India, for example. That's a scale, right? And SDN is software defined network. What it simply means that to control this gigantic mesh of router, it is again just like we said that we cannot manually go and fix computers, right? If it fails, and we said it fails all the time, we cannot go and manually do that. So we need a cloud computing to automatically degrade those machines and commission new machines, save the state and data and everything. Similarly, those same principles can be applied to the network of routers, where there are administrators or software which can be which control the entire mesh with some few commands. So that is called software defined networking. So you separate the control out of the data. Earlier in your books, you would read that to change the routing protocol, someone mentioned that they want to go and become a network architect. So I'm sure you might be reading this, that to read out your data within a network, you have to go and change the routing table manually. That's earlier thing. Now think about, so 2,000 router mesh, and all the intermediate ones you have to go and change manually each of them every time you want to change something. Every time you want to reroute a data packet from reaching from A to point A to B, you want to reach that from A to C, you have to change all these machines manually. It's impossible, right? So you want to take that control out into software, and that is precisely what software defined networking is. So these are the sort of three
Correct.
examples, and let's take a pause and see if there are any questions with past few slides.
Yep, we have couple of questions, Ayanji.
Right.
Let me just take it out sequentially. Okay, so the first question we have: what must be known before started learning cloud computing, and from where we can start our career as cloud engineer? Means I think the student is Deepak ji is asking for, like, what are the prerequisite for starting the cloud computing, and how they can start the career to the
Sure.
as a
Thank
cloud
you,
engineer.
Deepak. I think very relevant question, but wait for a few moments. We have other slides in the career where we will talk about that. So brief answer is start with the basics, and we'll talk about how to go from there. So there are two
Sure.
flavors. We'll
Okay.
talk about it. The next question, please.
Sure. The next question is, uh, what type of technology must be needed to know to generate cloud data storage center? So that the technology and the certification needed. So that I think what they wanted, Tusharji question is there. So
I maybe
let me
maybe
just try to.
they want to know
Mhm.
how to. I mean, what the knowledge required to build a
Correct.
storage layer
That
in the data center? Is that what it is?
correct. I am also trying to just relate that one. Oh, how type technology must we need to know to generate cloud storage. Okay, I think yeah, what they are asking is what is the technology needed to set up or generate, means I think it would be set up the cloud data storage center, and also is there any relevant certification that they can do so that they can become this thing on means the engineer who will be setting or um, providing an input in setting this cloud storage center.
Okay, I think the answer is quite similar to the earlier question about how much cost is needed. But if I may, so when you say data storage of data centers, so to set up a data center, there are a lot of things that is needed. One is the hardware aspect, and one is software aspect. For the hardware aspect, you would need physical machines for compute. You would need data storage both in terms of um, racks of hard drives. For the backup, you can even go up to tape drives. And within the compute nodes itself, you would need SSDs or flash or all those things for, there are many layers of cache, L1 cache, L2 cache, then it goes to RAM, then it goes to memory, and then all of those things are already built in. But probably that is not what you're asking. So those that is the physical aspect. There is a NVMe layer nowadays, which is for fast communication and very fast write and read. Um, but other than that, so I guess I'm not sure that this is the data layer and the
I
software
I
that.
I think
Yes,
Tusharji wanted, sorry to interrupt, Angie.
yeah.
I think Tusharji wanted to have it out like what is the prerequisite? Means what needs to be do a certification, or what technology needs to be known to
Hmm.
the person before he can apply for a job of this setting this cloud data storage center, means
Oh,
probably the engineers who are working there or the cloud architect, means it's like something they are wanted to know
sure,
the
sure.
technology background, like for take an example for Java, like if I wanted to build a program in microservices, I should be having a Java or something. Java should be Java, Spring Boot should be the basic thing I should be aware. So that is something that he is looking for.
Sure. So two things you should know. Again, it will come in few more slides, but you should know your basics of distributed systems, how network, compute, and storage all interact within each other. And now you have a choice of becoming in the software side or in hardware side. In the hardware side, if you are trying to set up real machines and network, you should have the knowledge of those gears. So if it is from Netgear or Cisco or Juniper, you should know how those gets connected, and each of these companies have their own certification and manual. Second thing is, if you are
Correct.
going from the software side, then you definitely need a programming background. Either it is Java or C++. I mean, if it is a high speed communication, it's all in C or C++ still. Java is in the application layer. Python is only most of the cases it is used in scripting or web page. But for your question, it would be mostly in Java or C++ or C. And you need a thorough knowledge of how distributed systems with storage and network are developed.
Correct. Correct. And to add it out to Tusharji, I think there is network topology, data structure, and socket programming, and all these things are there, which will help you into that. So
Absolutely.
I think that answers that. We got the response from Tushar. Thanks, ING. I think we can go ahead with the
Okay. Sure.
update next slides.
Sure. Thank you.
Thank you.
All right. I guess everybody is waiting for the career stuff, and maybe we
Correct.
stretched it out a bit, but probably that was a needed background. Anyhow, so for the basics, the last two questions I got is about the career, kind of gets answered in this slide. For for every most of the people here are, I'm assuming, are going to be fresh graduates getting into a job.
Yes.
So for
Yes.
for
Those are
all of
really the
those,
freshers.
right, for all the freshers, whether you are a bachelor's or master's student, it is your curriculum which is going to be enough. So whether you want to become a network architect, whether or you want to be eventually become work in a data center, or you want to form your own startup and plan for a data center and service, or you want to be a software engineer in various different fields, concentrate on your data structure and algorithms, learn how to apply them, and also refresh, be an expert on networking if you want to pursue that. uh, know your digital logic and computer architecture if you want to get into data center. This is also important. Computer architecture is bread and butter if you want to define whether it's a network topology, set up a data center, or plan for machines. You have to know computer architecture in and out. I don't know whether in your colleges computer organization and architecture are two different subjects. When I studied, I had two different subjects, but study them well. Even if you are just planning to become a software engineer, whether you plan on being on web developer, or whether you are doing system programming, please focus on your basics. Learn what the basic concepts of networking, computer architecture, digital logic, algorithms, and your choice of programming languages. These are the basic building blocks, and you should be able to build on that. So a few minutes
Correct.
back, Navneet also mentioned about multi-threading and parallel computing and sockets programming. All those are there in the building blocks. So distributed systems, even if you have basic concepts on the job, you would be able to learn as a fresher. Parallel computing and threads programming is something it is going to help you, not from the perspective of programming or getting a job, but while on the job, the clear, making grasping a clear concept of thread programming and semaphores and inter-process communication is crucial, and it is very hard to do. Even experienced seasoned programmers, if you ask them to do a complex multi-threaded program, many are going to fail, because they are going to write some program which is going to be faulty, and somehow they are going to get in a deadlock, or they are not going to operate. So take small examples, and it doesn't have to be cumbersome programs. Take small building blocks, example, few lines. Each thread can have few lines, and see in a complex interaction how can we avoid deadlock. Take a problem, take dining philosopher problem, and try to solve them. That is going to help you, in all through your career. Um, Again, I mean, I highlighted scaling here is because it's another thing where you want to make the concepts clear. So all of these that in the focus of basic building blocks, these 4 bullets, distributed systems, you don't need to understand how you're going to actually implement and how they are going to all these although I mentioned cap theorem, you don't have to know. All you have to understand is that if you want to, you know, host your service worldwide, how those data are getting transferred. That level is enough. Parallel computing threads and associated concepts is important. Scaling an architectural system is important because you have to understand, even if you want to get into distributed system or cloud computing, you have to understand what does scale mean. How is everything going inside your own home PC, when you just take it out in a global scale, how things change. The nature of problem changes. We cannot just say that if I make it faster, it's just going to work. It is not going to work. So you have to now think. If you guys are familiar with hash table, for example, one direct example. I mean, if you guys know hash table, if you don't know, it is simply you are putting a key value pair. You want to, for example, a cup of apple has 100 calorie, a cup of orange has 50 calorie, right? Let's take some example. And you want to look that up. If someone asks you a question that, hey, how much calorie are there in a cup of apple? You want to quickly look up. So you want to put them in a table somewhere in software form. And if someone says apple, you look up for apple what? So apple is the key, 100 calories is the value. So this is what hash table is. And this is only for people who doesn't know what hash table is. Probably you're just entering for software engineering, or you're in the first year. And when you write that in your computer, it's few lines of code. The same thing when you take it to global scale, it's rebranded as MapReduce. It is nothing other than a distributed hash table where you'd want to compute. Or for example, what does MapReduce do? I mean, if you want to look up some value, it takes that, it parses down, right? So just to give you an example, let's say Apple, right? And Apple, that word is distributed across globe. The first level is A. So it will go down one level and in a pool of machine which handles the letter A. And then another A, it will go down again. And when it goes to APPLE, it will reach to some pool of machine which handles this APPLE, the word, and then you get the value back. So this is one very simplistic example how you want to map a problem, break it down, and reduce the result up. Okay, we already talked about concept of compute network and storage. That is great. Um, okay, so second topic, second bullet, we also have kind of discussed that you don't need a specialized knowledge. The last one is
Correct.
one aspect that is an observation, a suggestion per se, is to early on in your career try to decide which track you want to take. I mean, there is IC is individual contributor. Most of the software engineers are individual contributors, and there are managers, right? So if you decide which one you want to take early on, that will help your career. Has nothing to do with cloud computing or anything, just one small tips. All right, we'll go to the next one, and then after this, we'll stop once more. We have 8 more minutes, but let me breeze it through for a few. Actually, let's finish and then we'll stop again. Okay, so the answer changes a bit if you are a PhD candidate, for example. If you're a PhD candidate, you have a choice of specializing on something, and you can choose distributed systems or networking or cloud computing or something like that, algorithm research, and then you will get an interview opportunity, which is probably 2 or 3 level higher. And they are going to expect that you know that. If you are also researching one of the area where you can use AI or ML in cloud computing, that is another route. There are data center topology we talked about a little bit, or scalability. And when you are getting into, we have a couple of questions where they said that how am I going to go and build a data center or be a data center engineer? You will need to know, in addition to the control system and the equipment or hardware, you also need to know how power, cooling, compute, topology, storage, everything works. Because, for example, one of the hot problem here, that's why I highlighted power, is energy consumption. The more machines you have, the more power it consumes and the more expenditure there is. So it is one of the biggest and hottest research area because everybody wants to reduce the expenditure. So and people are building these data center, below the ocean, on the mountain tops or very cold desert, so that they can reduce the cooling expenditure. So both power and cooling are taking power, takes energy, which contributes to electricity bill. Moving on to the
Correct.
current challenges, some of the challenges we would highlight. I'm just rushing through now because we have talked about the career and almost near the end. Performance is one where we already talked about a bit when we said why. The larger the scale, more complexity, the more network nodes are there, more hops are there, more delays, right? Which means degraded performance. And suddenly, if the user base doubles and we see buffering in YouTube video, that is not good. So we need more research
Agree.
there to improve performance. Taking back to the khichdi example, right? I mean, suddenly from 100 grams or 150 grams rice and dal, we want 100 kg rice and 200 kg dal. How do you scale that? And how do you even cook that? I
Correct.
mean, in one karai, it's not even possible. So maybe in a longer, but besides the topic. Security is one of the biggest hot topic because how many hackings are going on, personal, they know your personal data and go and replicate your Facebook account and do steal bank account information. The more complexity and scale means the more opportunity for those hackers and black hat ops to go and exploit, right? Data protection and privacy is also there. Facebook is selling our data. It's all well known. Every company nowadays which have free service selling our data. How do companies want to prevent that to get into malicious hand, and then they steal your identity and so on and so forth. Cost optimizing power again is number one, along with other cost reduction. If it linearly increases with the scale, then it is almost impossible because you would always have redundancy, which means wasted money. seamless multi-cloud is kind of solved, which means that Google provides something, Microsoft provides something, Amazon provides something. As a user, you should have a choice. You should not go and only use Google or Amazon or whatnot. You should be able to always move around, and they should provide a hybrid cloud for you. Last slide, pretty much last slide, is the open problems for people who are doing advanced research or PhD, or if you want to do. Most of the open challenges are still there, but some of the few top ones are application of ML. ML is still in the infancy. I mean, there is a lot of things that needs to be done. One example why ML is infancy is automated driving. Tesla is coming up with level 7 automated driving. It is still
Automated.
years away, right? So think about the scale of data that is coming in. We talk about processing of data quickly, right? You have to get the sensor data from all around while you're driving. You have to analyze that and produce results and instruct the vehicle in real time. It's not there. Cost saving, low power. So everybody knows about carbon footprint. Our earth is dying because we are chopping down trees. All these greenhouse gases are getting generated. Computer we are running. Everybody heard about Bitcoin. Bitcoin is now in flip-flop because do you want to do more computing and generating more carbon footprint, or should we abandon Bitcoin? And so you see it went from few cents few years back to now almost 60K down to 40K and whatnot. Elon Musk is tweeting left and right. Not sure which one is relevant or not. So that is one. Network topology we talked about a little bit, how fast you can transfer data. And mobile and edge computing we did not talk about, but that is one of the another thing. So you want to play 4K video and even beyond in your small device. You want to do everything. Everybody has already shifted from desktop to laptop to iPad. Everybody is continuing to shift to mobile devices. So all of the discussions we have done today, you want to realize that in your mobile device. That is also another hot area and research topic. Here are a few further readings. So one of the things I personally liked a lot is Indrajit Gupta's cloud computing. Covers most of the technical aspects very well. And here are a bunch of courses that are offered free by IBM. And I'm sure Navneet will be able to help more on these.
Yes.
Okay, great. So we are almost 2 minutes to finish
Yep,
time.
2 minutes to take. So I think we are having two questions we are having. And Deepak ji, I think Deepak, we have answered your earlier questions that you have asked what needs to know before started learning cloud computing. So that is also covered in one of the slides. I think you are clear on that. So now the next question is from Nikhil Gupta. What they wanted to understand is suggest some certification or the degree program to develop industry level cloud computing skills. So ING, do you have any?
So I guess the last slide we so for example, Navneet, you can talk about whether IBM gives certification. I'm not sure about that. But for example, Indrajit Gupta's this course, you can audit or you can actually take the course. You can look at
Okay.
either IBM or Coursera or Udacity, some of them. There are international universities, they offer degrees there as well on all of these subjects.
Correct. And to add it out, our IBM learning platform in which you students have registered, where IBM Skill Build program, that is also having a lot of courses, and that provides a certification and the badges for that. There are a couple of certification on the Cisco also, but the links I will be sharing post this session. Whatever the links are displayed in your screen for further reviewing, reading and viewing, so you can take it out further. So I think Nikhil, I hope that I answered your question. Next question is from Shubham. What he wanted is how the search works. Actually, this is very interesting question. When I was reading it out, I think being as an industry, we know that, but this is a question that is for the students and everything. So what they are telling is how search works. When we search something and get exact result, how hashtag works, how tags work on web and applications such as Tinder, etc. or Omegle or something, and word coach by Google when we use Google dictionary. So I think what ING he wanted to understand is basically the how the search works, how internally it search into the database and then show the results based on the relevant results according to that.
I think it's, I think it's a very broad question, but
I know, I
you'd see that before Google, there were Alta Vista and Yahoo and Lycos and all of those. The two things used to happen. One is the search used to be very slow, and second thing is the results you'd get were not very relevant. You'd probably get relevant result in second end of second page or fourth page or something like that. When Google came in, and these are all again public data, what Sergey Brin and Larry Page did, they were PhD students, they dropped out and they sort of invented PageRank. What that does simply, Google now has moved on from PageRank and did a lot more things, but PageRank is still relevant. And you'll get and a lot of free software. For example, Lucene is a free software which does search very well in your local data, and it uses the same thing. So PageRank, what it does is it counts the links between different pages, and the more cross link you have, let's say page A refers to B, refers to C, and C refers to A back, so A gets count of 2. Very simplistic example, which means out of these 3 pages, A gets ranked higher. So more people using that page and referring that page gets higher result. A similar thing is when you can think in real life is, for example, word of mouth, right? You have 5 shops in your locality, and the more people say that Ram's shop is better
Hmm.
than Jadu's shop, in your mind it ranks higher, and people want to buy more from there. You get, and it's a vicious cycle. The more people buy from Ram's
Correct.
shop, the goods keeps on moving. You get fresh things, and the last guy, they don't sell, and they keep on getting down. And one related thing is, you will see the term SEO, since you are interested in search engine optimization, right? SEO. So Ram is doing super duper business, Jadu is okay, and maybe Sham is the last guy. He thinks that, hey, I mean, my goods are not moving, so I want to do some optimization. So he creates some, his paid guys, and says them, hey, I mean, why don't you say good things about me? I'll give you 5 rupees every day. So that is search engine optimization.
Correct.
So how do you want to do this? So your page rank increase more and you get listed higher. I'm not talking about paid ranking. I mean, usually paid ranking comes at the front. You pay money, that's different. But freely, I mean, why do you want to do SEO? Because paid rankings are expensive. You want to spend less, but you move your rank higher. Anyway, coming back to the search, coming back to PageRank, that is exactly how PageRank works, and that is crux of it. Other than that, the storage. So this is how you get relevant result. How do you get fast result? Is initially in the early days, you type out a question, enter search button, the whole text goes, and then it gets searched in
Correct.
database, it distributes database, comes back, and it gets rendered. Now, if someone does that, it is not going to work. It is going to be minutes before you see the answer, right? But this is the exact thing. Still, it is getting done in the Alexa or those devices because the user base is small. Search user base is worldwide. So you would see that in most of the cases, when you type a single letter, there's a drop down and they show suggestion that, oh, what could be. I'm not talking about, let's forget about suggestion, but how that happens is every letter you type that gets transmitted. It is no longer word or full sentence. When you are doing there, it is already in the background doing a massive MapReduce job, and it's already getting results on the background. And as you type, it keeps on matching, and at the end you get the result very fast. Second is Google has its own network fabric, and in the regular internet, over the whatever we do public domain doesn't work. Google has its own leased trunk line, so that your question from India to US is served through that trunk line, dedicated lines. Same thing
Correct.
everybody is doing. I mean, Tesla and SpaceX, everybody has their own network. They have like, I don't know, hundreds of satellites now. It is going to be increase. It is going to improve more. I mean, that's how why satellites are coming in, is because the more user base increases, you have to you want to increase the speed of communication. Otherwise, it's going to get bottlenecked. So these are the few of the things you can think of. And the backend storage, if you guys know what try is, think about the backend storage is like a try, character wise, right? A very simplistic representation. If you don't know what try is, Google it, what try is, you'd see it is very similar to the Apple example we gave, a very massive hash table. So these are the answers in crux. I mean, it's a topic for a full day, so I'll
I
leave at
agree.
that.
Okay. Thank you, Angie. I'm just waiting. I'm just giving 2 more minutes. If anyone have any questions, they will
Sure.
type it out. So I'm just waiting for 2 more minutes. But I think it is really helpful, uh, because you have touched each and every concept of the cloud computing, and you have tagged with the real world example like Amazon, AWS, Alexa, and then Siri and everything, which is in our day-to-day communication everyone is using.
Sure.
So, students, do you have any other questions? You can just type us the questions. We'll take it out. I know that we are just overrunning that by 5 minutes, but I'll just take 5 more minutes
Sure.
because it will be late for ING also. Okay, so there is one question: which programming language should be perfect to start with cloud computing?
Okay.
So I
So again, there
think
is no one answer, but I will say you this, that it depends really on at what layer you're operating. If you are cloud computing is a very large concept, as you have seen or heard, that starting from the very low physical layer where every communication between the processors has to be very fast, to the application layer where someone is actually saying Gmail, for example, is an application layer. If you're working in Gmail, maybe writing in Java is okay. But if you are
hmm,
working at the very lowest layer of the stack in the network, it would be C or C++, because you need really
correct.
fast programming and performant ones. So if you look at the OSI, I mean, perfect. I mean, I guess the best answer would be, if you are looking at the OSI 7-layer or TCP/IP 5-layer protocol stack, think look at what each layer, what are the services, whether you are in network or data link or really at the top application or presentation, and see what programs are there. If you're in Gmail or YouTube, those are in presentation, or Netflix front end. So there, Java is fine. At the lowest layer, data link and all, you need C++ or C.
Correct. Okay. Thank you, Angie. I think Jagriti, I think we answered your question. One last question we will be taking now is which cloud platform is best? Again, this is again a very generic question, but Angie, I would
I
say.
Okay, so I cannot say which is blessed. You have to look at it. But I can say you what are the market leaders are. AWS is market leader at this moment. Then it is Microsoft with Azure, and
Yep,
the third is GCP. That is what it is. But there's a fierce competition between all of these, and everybody is trying to get more piece of pie.
correct. Okay, so I think Chetanji, we have taken your answer. Also, you can do a Google on what is AWS and what is that Azure, Microsoft Cloud, and everything, and you can. So with this, I think I'm just taking. Yep, I think we are good. Okay, we have no further questions, so we are good to go. Thanks a lot, Angie, for your time. Really, from on behalf of students, I wanted to say big thank you to you because you have taken your time from your busy schedule and providing the complete details, and also you are having like the real world example I was talking earlier also, right, how to map it out. So that's a and that's really good, and also you have taken all the questions and providing a clarification to the student.
Sure.
So
Thank you so
again, big
much,
thank you
and
to us from the
sure. Thank you, Navneet. And thank you so much, everyone, for patiently listening to much of the rant I have done. I mean, it's not a problem for me at all. I really enjoyed, and I would be really grateful if, out of all this session, even if you guys had a little bit of help in whatever perspective, that would be awesome.
yes. So we are
That is the
getting a lot
reward
of
for
thank you
everyone.
from the students also,
Sure. Thank you so
and
much.
we are getting a lot of thank you from the and
Yep, I can see
on
that.
behalf of Smart Now. On
Thank you.
behalf of Smart Now, we thanks students also for the patience listening on that. So with
Absolutely.
this, I'm
Absolutely.
just closing the session. Thank you
Okay.
and
Sure.
have a
All the
nice
best,
weekend.
everyone, and I wish you a
Thank
lot
you.
of success in your career.
Thank you, Angie. Thank you.